Hey guys, welcome back to another course. Um, this is 2019 Kaplan GED book, and we are working on math. So the last problem, this bit kind of like part two to the last problem, but it was in using the percent formula, and the last, not problem, but lesson was solving for the base. This time we will be solving for the part. We actually, sorry about that. It's in the reverse order. Last time we solved for the part, now we're solving for the base. Even though we did do solving for the part last time, we did cover some solving for the base as well because they are kind of intertwined, and that's just how GED has it. Nevertheless, they have a separate section for solving for the base, as you can see right up here. Solving for the base. Hip hip hooray. Who doesn't like to solve for the base? I know I don't. Oh wait, I'm not supposed to say that. I know I do. My bad. Just joking. Little humor. Okay guys, so let's get started. You can briefly go through this here. So for example, when you solve for the base, which is this shadowed out area or shaded out area here, basically anytime you're solving, anytime you have the part and either the rate or the base, you will divide. Okay, you'll divide the part by, if you have the base, it'll be the base. If you have the rate, it'll be the rate. Okay, so let's see. For example, in math class, 75% of the students got at least a B grade on the final exam. If 18 students, by the way, I'm reading example 3 here in case you didn't know. If 18 students got at least a B, how many students are in the class? So we have the rate here. The percent is always the rate, okay? And we have, if 18 students got at least a B, how many students are in the class? So we know that this number here, 18, is the same as 75% because in math class, 75% of the students got at least a B. And here it's reiterating, if 18 students got a B. Okay, so we know that this is the part, which is equal to 75%. Okay, how many students are in the class total? So analyze the situation. The 18 students are part of the larger class. You know that the 18 students are 75% of the whole group. So 75 is the rate and the base is unknown. Okay? So use the diagram to cover B. Use the diagram. Cover B for base. You need to divide the part by the rate to solve the problem. So as you can see, what they're doing here is, so anytime you have the rate here, you need to change that to a non-percent number, okay, which is, I call it a regular number. So how you do that is you do, as you can see here, they put a 0.75. Okay, here it says convert the rate to a decimal. Okay, 75% equals 0.75 and divide. There are 24 students in the class. So I said this last time, I'll reiterate it. Anytime you have changed the percent to decimal, you will put 2, you'll move the decimal point 2 spaces over. For example, 75%. We know that the decimal point is here, so we'll move it back here. Now we'll do as they did. They divided the part here, which is 18 students, divided by 75%. Okay, which is, they changed to a regular number, which is 0.75. So you'll always move it 2 places over when you're resolving or converting the percent to a number, okay? to a decimal number. For example, if it was just 5%, you're like, there's just one here, one digit. How can we move it 2 places over? Well, you would take that presumed decimal, which is be on the right side of the number, move it once, move it twice, and add a 0. So now you have 0.05. Okay, so these are concrete steps or formulas that you would always do in every situation. Okay, so that's the idea there. There was something slightly different here, trying to on the second example, but just to complete this one here. So this isn't a division class, so I'm not going to go too deep into this, but you should basically, since now you have the 0.75 with division, you can't have a decimal, you can't divide by a decimal. So that's why you move the decimal 2 spaces to the right. Then you also have to do the same thing here with the 18. So these 2 zeros were not there before. It was just 18 divided by 75%. They had to change this to 0.75, then move decimal 2 places over again to do this division problem, and then with that they had to add 2 zeros here, okay, to make up for the 2 places they moved here. So this was just 18 before, and they came out with that problem. Okay, here let's see what the difference is. Not really much of a difference. It just says the workforce of Eastland Incorporated is growing rapidly. The number of employees this year is 25% of the number last year. If there are 135 employees this year, how many employees did the company have last year? So here it's just talking about how sometimes the rate will actually be larger, and which in turn means the part will be larger than the actual base. Typically the base is larger, but sometimes the rate and the part will be larger as well. Okay, but here you do the same thing. Like I said before, it's always firm that you move it over 2 times. As you can see here, they changed the 225 to a decimal, and notice how they only moved the decimal 2 spaces to the left. Then again, when they actually put it in the division problem, they had to move it back 2 spaces to the right. Okay, and then they added 2 zeros here to take up the place values there. Okay, so let's get started. We're pretty much gonna go over this anyways. Let's see. Okay, so here we have it. I may not do all of these just because it's basically kind of redundant doing the same things over and over. Let's see. Okay, so number 1 here is $35 is 20% of what amount? So we have $35. We know that it's 20% of the total amount, so we know that this is only part of the total amount. So you always divide the part by the rate. Okay, so 35 divided by 20%. Okay, remember, anytime you're doing with all of these percents, you will always turn it into a decimal number. So, okay, we'll just write 35 divided by, we have 20%, we change it to a decimal number. Now the decimal is right here, okay? The new decimal is right there. So now we do 35 divided by 20, okay? it says not to use, you may not use a calculator here. I'm going to use a calculator for most of these. I'll do the first one without a calculator, since again this isn't about doing a division problem. More than anything, this is about knowing how to set this up. You should already know how to do division, which is why I'm going to use the calculator. Also, it's a lot faster, but knowing how to set this up. So, okay, now we need to divide 35, which is the part, by 0.20. Okay, so we can't have a decimal in a division problem, so we need to move it over 2 spaces. Now we have no decimal since it's to the right of the 0. So, but we do need to make up for those values there. So we move that decimal over 2 spaces as well. Now we have 3,500. So 20 goes into 35. How many times goes in there? 1 time. 1 times 20 is 20. We have 35 minus 20 is 15. 20 goes into 15. No, it does not. Bring down 0. 20 goes into 150. Well, 20 goes into 100 5 times. Then it goes into 52 times, which makes it 100. Which makes it 7 times. Okay, so 7 times 20 is 140. 150 minus 140 is 10. Now 20 goes into 10. No, it does not. So we bring down this 0 now. Put it here. 20 goes into 100 5 times. Okay, 5 times 20 is 100. Hip hip hooray, we have our answer, 175. Okay, how that would look on the calculator is 35 divided by, see, we just do 35 divided by 0.20. We don't do, this is on the calculator. We don't move over the decimals and stuff because the calculator does all that for you. 35 divided by 0.20 equals, what do you know? 175. Okay. So, hello, clear canvas. Number 2, 5% of what number is 14? So we have the rate here, and 5% of what number? So we know that the number that 5% is of is not 14, but the part is 14. Okay, so do the part, which is part divided by part divided by 5%, which is the rate. Okay, let's see. So remember, the assumed decimal point is right here. You need to move it over twice. Okay, so that will be the problem right there. New decimal place right there. So 14 divided by 0.05 equals 280. Easy enough. Let's see, 32, number 3, 3.2 is 50% of what number? So here again we have the part, which is 3.2, So we'll need to divide 3.2 by 50%. So 3.2 divided by, remember we don't just do 50. Since there's 2 here, 2 digits, we move the decimal point 2 places, so it'll be 0.50. And that's 6.4. We could have actually just looked at this and seen that it would be that, because 3.2 is 50%, then we would just times 3.2 by 2, which would be 6.4. Okay, number 4 is 170 is 85% of what amount? So 170, we know that it's 85%, so it's just the part. Okay, it's equal to 85%. So 170, which is the part, divided by the percent, so 0.85 equals 200. Okay, so number 4 is 200. Number 5, 24 is 80% of what number? Since we know 24 is 80%, then we know it's the part. Okay, 24 divided by, remember, 0.80 equals 30. So 30 is the number for here, for number 5. Just give you an idea, guys. Think of 85, or these percents here. If they're under 100, then they are only part of a whole. They're not actually a whole yet. Okay. However, if like this here, 125, since it's over 100, then we know it's 1 plus 25% more. Okay. Because a percent is always part of 100. So let's see. Number 6, 105 is 125% of what amount? So we know that this is part. Okay. 105 divided by, so in this case here, remember how the 125 with the percentage, we always move over 2 places, so same thing here, only 2 places. So now it's 1.25 to equal, like I said, that part. 125 makes it 1 whole plus 25% more. So divided the part, 105 divided by the rate, which is 1.25, equals 84. So 105 is 125% of the number 84. That's what you can think of it as. 105 is equal to 125%. Okay. But the standard is 84, which is, if you want to think of something that never changes, the standard of percentage is always 100%. Okay. So there you go. So that's more than 1, because we have 105 over 84. 105 is 125% of 84. Okay. Now we have number 7, which is 190 is 95% of what number? So since we know 190 is 95%, we know it's the part, because it's not 100%. 190 divided by 0.95 equals 200. So 190 is 95% of 200. Okay. Now, number 8, what number is 15% of 60? So now we have the part, the rate and the base here. So what number is 15% of 60? When you have the base and the rate, only time you do multiplication in this formula is when you have the base and the rate. Otherwise, if you have the part and the base, or the part and the rate, you would do division. I'll just write this one out for you since it's the first one. What number is 15% of 60? So you do base, which is 60, times the rate, which is 15. And remember, even with the base, you would always move this over 2 times. Okay, move the decimal base over 2 times. So now you have 60 times 0.15 is 9. Okay, so what number is 15% of 60? 9 is 15% of 60. 90% of 15 is what number? So 90% of 15, we have here 90 is the rate and 15 is the base. Okay, so we would multiply this in that case, just like this here. So the base, which is 15, times the rate, which is 0.90, since we move over that decimal 2 times, is equal to 13.5. And since we're talking in currency here, you don't talk about money like, oh, I have $13.5. Okay, I mean, technically that would work, but you say I have $13.50, because this 0 to the right of the decimal point doesn't actually add any value, but it, in our money system we use in the dollar currency, at least, we use 2 digits for the cents. Okay, so let me clear this canvas. I didn't say cannabis, I said canvas. Okay, so number 10 here, $42 is what percent of 168? So we know $42 is the part. Okay, so far we haven't had a part and a base together yet. I don't believe we have, at least. All these, when you see percent, it's because there's a rate, and in all these there was a rate plus base or a rate plus part. So when you have, like I mentioned earlier, when you have the part with anything else, then you divide it. So 42 divided by 168. Okay, so let's do this. 42 divided by 168 equals, so we have 0.25. So just like with the decimal point, not decimal point, sorry, with the rate, how you take 50%, or we took 50%, for example, in number 3 here, and to actually solve it, we had to move it over, the decimal point, over 2 places, and then solve the problem. Well, with the part and the base, when you divide it like that, we got the answer, which is 0.25. So you do the reverse of what you did here. So we don't want this, we want to turn this decimal number into a percentage. So, and again, you do this every time as well. So what I'm telling you here, you can apply to all the problems with the part and the base like this. After it's done, you move it over 2 times. Okay? Now you have 25%. Okay? which they both mean the same thing, but you can't write 0.25%. 0.25 is 25% of 100, which the same thing, 25% is 25% of 100 as well. So just do the exact reverse. The only difference is this one you do, moving it to the right, you do after you've done the equation or the multiplication problem. The other one with the percent there, you would move it to the left before you actually divide the problem. Okay, so here we have number 11. So 150 is 200% of what amount? So 150, we know it's equal to 200%. So we have the part here, which is equal to 200%. Let's see. So we have the part plus the rate. So 150 divided by, remember, 2 point. We don't actually need to write 0, 0, because anything to the right of this decimal point here will have no value whatsoever, particularly when you're doing it on the calculator. I'll do this one over here in, what do you call it, on paper. 150 divided by 200, which let's say before we actually put it there, put it right here, as in setting up that problem, we had moved 200 to the decimal 2 places over. Like that. So we basically move it back, and let's see. I think clear this one. So basically we have 150 here divided by we're on 11 divided by 2.00, which we don't have to write, equals, that's actually the wrong answer. Let's see. Okay, I'm going to go back to doing it this way. 200, since we had to write that to decimal. Whoops. Move this over because we had moved it over 2 spaces, so now we have to move it over 2 spaces here, but we also have to add that value here. So add 2 more zeros. Sorry guys, I'm writing with a trackpad, so I don't actually have a mouse. It comes out kind of sloppy, but these are zeros, believe it or not. So 200 into 150 does not go. 200 into 1500 does go. So it goes in there 7 times. 7 times 200 is 1400. 0 minus 0, blah blah blah. Well, 1500 minus 1400 we know is 100. Okay. So now does 200 go into 100? It absolutely does not. So we need to bring down this last 0 here, make it 1,000. 200 goes into 1,000 5 times. So the answer there is 75. Okay, let's clear this. Okay, now let's see. Number 12 is 15% of 62 is what amount? So we have 15% of 62, which would mean we have the base and we have the rate. This being the base, this being the rate. So we would multiply these, okay? So base times rate is the formula. 62 times, changing the percentage to decimal, is 0.15 equals, since we are using currency, we would add the 0 here to make it $9.30. This still means $9.30, 9.3. But since we are dealing with currency there, the correct form would be 9.30. Okay, so we know that 15% of $62 is $9.30. Okay, 9 is 1% of what number? So 9 is the part, and so we would, remember we need to move this over 2 places, so we would add a 0. Okay, so it would be 9 divided by 0.01. Okay, let me do that again. 9 divided by 0.01 equals 900. Okay, so 9 is 1% of 900. What percent is 126 of 140? So 126 is the part, obviously, and this would be the base. 140 would be the base. So 126 divided by 140. Remember, this time we move the decimal point to the right after we do this calculation. To the right 2 times, that is. So 0.9, okay, which would be 0.9. Hello. Okay, 0.9, moving it over twice would be 90. So we have 90%, okay? What percent is 126 of 140? It's 90%. 65% of 1200 is what amount? So 65% is, let's see, the rate, then 1200 is the base. So base times rate, 1200 times the rate of 0.65 equals 780. Okay, sorry, I accidentally pushed equals twice, so it went to 507, but it's 780. Okay, now number 16, this is a little bit of a tricky one. 5% of an amount is 156. What is the amount? Okay, so it's, you can think that this is the base, but it's actually, if you read closely, 5% of an amount is 156. So 156 is equivalent to the 5%. So it's only part of that 100% that we're looking for. So we divide 156, we divide the part by the rate, which is, remember, moving it over twice, moving the decimal over twice, 0.05 equals 3,121. So 156 is 5% of 3,121. Okay. 2.5 of a number is 2.5% of a number is 100. So we know that 100 is equivalent to 2.5%. So 100 is the part. Okay. This is the rate. So let's see. Okay, guys, to change a fraction, you have to know your fraction equivalency chart. Most of you probably know that half is equal to 0.5, okay, in the equivalency chart, like fractions to decimals equivalency chart. You can look that up. So let's think of this. Let's write that instead of 2.5. We'll write it as 2.5. Now we've resolved that fraction, but we still have to move this over 2 spaces, okay? So 1, 2. Now we have 0.025, okay? So 100, which is the part, divided by 0.025 equals 4,000. Okay, so 2.5% of a number is 100. So 100 is 2.5% of 4,000. Okay, and you could always, this is the base and this is the part. You can always check it by, what do you do when you have the base and the part? You divide the part by the base. So 115. Remember, we're going to have to move decimal place over 2 times. 100, which is the part, divided by the base, which is what we got, 4,000, equals, see that? 0.5, that's what we started with. So we know that is correct. Okay? And if we were to move it over 2 spaces, when I say move it over, I mean decimal, 2 spaces, there we go. Any 0 to the far left is valueless, so we come back to what we had. 2, decimal is here, 0.5, which equals 2.5%, like we said in the beginning. Okay, now number 18. What percent is $15.60 of 156? Let's see. $15.60 is the part. $15.60 divided by 156 equals 0.1. So remember, we do the reverse and move this point over 2 spaces. Okay, so if we moved it over 1, okay, let's do this here. Draw it here, 0.1. That's what the calculator gave us. We move it over 2 spaces. 1, 2. For that empty space, we add a 0. Now, we know that it's 10%. Sorry, this trackpad is acting funny. 10%. Okay, so $15.60 is 10% of $156. Okay, a few more, 4 more to go, guys. Hip hip hooray. Choose the one best answer to each question. Okay, so there's some of these. I believe this one over here has two possible question or possible answers, but only one is the best. I think the other one's incomplete. I'm not certain though. Okay, Kevin's total payroll deductions are 30% of his earnings. If his deductions add up to $369 for a 2-week period, how much were his earnings for the period? Guys, pause this, try and figure this out. See if you can wrap this around in your brain and come out with the proper equation, okay? Okay, hopefully you've unpaused it now. Okay, so Kevin's total payroll deductions are 30%. So we have the rate, 30% of his earnings. If his deductions add up to 369 for 2-week periods, so we know that 30% is equivalent to 369, okay? For a 2-week period, how much were his personal earnings for the period? So we have a trusty old calculator. So we have the rate and we have the part. So the part, 369, divided by the rate, which is move the decimal place over twice, 0.30, equals 1,230. That is your answer, C right there. Okay, now we have a little graph here, or I forget what you call this. But anyways, let's say chart. A city council established the following budget to improve public transportation. If $72,000 is allotted for equipment, what is the total budget for the project? So let's see, equipment is 6%. Okay, that's the budget they gave for equipment, 6%. So we know that 72 equals 6%, which is 6% of the 100%, which is what we're shooting for. We know that 72,000 is then the part. Okay, so 72,000. 72,000 divided by 0.06 equals 1,200,000. C is your answer right there. 72,000 is 6% of 1,200,000. Okay, number 21 here, y'all. If I could put my little cowboy twang in there for you, y'all. Let's see. 21. Jack earns a 5% commission on each sale. If he is paid $160 commission, if he is paid as in $160 commission, which of the following expressions could be used to find the amount of the sale? So, let me see what, I want to look back in the GED book and see where we actually learned this particular one in, but it was quite useful. Which was, I believe it was proportions, ratios and proportions, something like that. Yeah, ratios and proportions, which kind of are similar to percents. But yeah, basically they taught us, I can't remember what number lesson that was, but if you go back a few lessons, and I think look up ratio or either proportion, one of those. But basically how we set it up was, so Jack earns 5%, so the equivalent percentage is always here. Okay, so we know we have 5%. Okay, and we know that 5% is always the part of 100, so though they don't say 100% here, we know that 100 needs to go underneath here. Okay, So 5% commission on each sale. If he then was paid 160, we know that 160 is, so think of this as equivalent, guys. 160, according to our problem, is equivalent to 5% according to our problem. So what we're missing is what 5% is the total of, okay? 160% is 160 is 5% of this number here, which is the missing variable. So how I explained it in the other lesson was always multiply towards the side with the missing variable diagonally, okay? So we can't multiply this way because that is the missing variable. So the two numbers that we do have, which are diagonal, going towards the missing variable, which is the x, is this direction. So 100 times 160. Okay, let's see, 100 times 160 equals 16,000. Then we divide it horizontally this way, okay? So divided by 5, that's the answer to the question. Though they're not asking for the answer, asking how you set it up. You can see we did 100 times 60, then divided by 5. So you can see here 160 times 100, okay? Whichever way you do this, if you set it up with 100 first and then 116 back here, it still come out the same number. Then divided by 5. Okay, so that's what we did. 100 times 160 divided by 5. It will always be this way. So B is the correct way to set it up here. Okay, because if we set it up like, we know 3200 is our answer. Okay, if we were to set it up or do it like this, 5 times 100 divided by 160. If we don't get 3200, then it's incorrect. 3.125, see? So it has to be set up like this. Okay, American Loan Company mailed 3,600 customers an application. So the total amount, we know right there that that's most likely the base. 3,600 customers, an application for a new credit card. Only 20% of the customers returned the application. So we have, okay, of the customers returned the only 20% of, okay, the question here. How many customers return the application? So we have the base and the rate. Remember, base is always multiplied by the rate. So base times rate. 3,600. And remember, change the 20% to decimal number. So we multiply that times 0.2. We don't have to add 0, but I will, because any 0 to the far right of the decimal point is meaningless. 720. So 720 is 20% of 3,600. Well, guys, I hope that helped. If you feel like it did, please subscribe, hit notifications so you can see I'm going basically through all of the lessons in the GED step by step, covering all the problems or almost all the problems, like almost all the individual problems, unless it gets a little too redundant. But I am going over each section so you can learn how to do each section in the math. Okay, so if that's valuable to you, please subscribe and send to somebody else, share it with somebody that you know is going through GED, somebody else that you may know. Anyways, thank you very much. See you later. Till next time. Bon voyage.